And in fact, this low-level waste decays with time, as our low-level waste does, because it's short-lived material. And if you plot it on a graph and give a direct comparison of the inhalation risk from this material compared with the inhalation risk from the material that's in your garden already, you'll discover that it's not only a tiny fraction of 10,000th, but that radioactivity decays also with time. You'll notice this is a logarithmic plot. So in 10 years' time, the risk from the low-level waste is 10 times less, and in 100 years' time, it's 100 times less. So in fact, that would be a perfectly acceptable policy to follow, except that we can do even better, and we wouldn't even put it near you, we can put it somewhere else. But the risk anyway is negligible, even if we did put it to you. So the health risk from low-level waste is tiny, even if we dispose of it in the top meter of your backyard. But we don't have to disperse it at all. By actually keeping it concentrated, we can do better, and of course, we can do better by not putting it in your backyard, but putting it somewhere else. And indeed, you can also analyze what effect it has in the area where we put it, and on any calculation you conclude that the effect is trivial. You also have to remember that the nuclear industry can make this waste safe because it's concentrated, and it's therefore much easier to contain and control. And we can do nothing at all about the radioactivity in your garden, at least nothing that we can financially afford, because it is so well dispersed in a lot of non-nuclear material. But if in fact low-level waste is such an unimportant risk as I see it, what about the other kinds of nuclear waste? And let us look at the next category, the short-lived intermediate level waste. This is the material that comes directly from the power station. It is typically steel material that has been activated in the neutron flux of the reactor. It's concentrated and is therefore very radioactive, but it is relatively short-lived, and it decays in a short time. And as you may know from the newspapers, this is also material that we would like to dispose of sometime this century. So let's examine it, and let's do our thought experiment on that also. As I just warned you, it is more concentrated, although the amount of material is much less, so in total the radioactive hazard is not significantly important either. So therefore, let us have a look at short-lived, intermediate level waste. I'm now going to show you some real short-lived intermediate level waste. It is waste that has come from the Trawsfynydd reactor. It must now be about 10 years old. So far as I know, it is the first time this has ever been demonstrated in public. You see, I have it in a lead pot, and the lid of the lead pot is very heavy, and inside it I have a sample of short-lived intermediate level nuclear waste. It is indeed very radioactive. Very radioactive. Here again is your background counts. This is, I'm not showing you something that is artificial or pretending. It is the actual, real, short-lived intermediate level waste. And you see I am treating it with some care, with some respect, but not actually with any fear, because, in fact, there isn't a great deal to worry about on radioactivity. There is some to worry about, but not a lot. Not a lot. And therefore, in fact, that's short-lived intermediate level waste. Let's continue our thought experiment. How much is there from your lifetime supply of electricity? It would require a box about this size from your lifetime supply. Let us suppose also, in our imagination, that also is delivered to you on your 60th birthday. And suppose you also bury that in the top meter of your garden. And let us also do a calculation of what is the risk of that compared to the risk from the radioactivity that is already in your garden. Then it is only about 1/3000th of the risk. And if I show you the graph again that you have had before, then you see that it is not only 1/3000th when it is first made, or when it is first delivered to you, but it decays rapidly with time, and therefore, after some years, it looks more like low-level waste than intermediate-level waste. It is more concentrated, but there's a lot less of it. And so there's not a whole lot different from the low-level waste that I showed you before. And of course, because it's concentrated, we can isolate it from mankind better by surrounding it with a great deal of concrete and other material. So therefore, the risk from that, I think, on any objective assessment, is very tiny compared to everything which faces you in your everyday life. And that's the material that we would like to dispose of sometime this century. But maybe you say to yourself, why do we need to bother with that? Perhaps you would prefer to volunteer to have your electricity come in from coal rather than nuclear power. Perhaps you would prefer to have it come in from coal. Well, I'll give you that choice if you wish. Let us then next suppose that your lifetime supply of electricity comes from coal. And then on the same thought experiment, you must permit me to bury the coal ash in your backyard. And let's examine what that looks like. Now, a lifetime supply of electricity from coal produces 20 cubic meters of coal ash. That coal ash contains 600 kilograms of potassium, 0.2 kilograms of uranium, and 0.6 kilograms of thorium. And here is a picture of 20 cubic meters of coal ash. And we are going to deliver that to you on your 60th birthday. And we will invite you to dig that into your garden. And we will compare the radioactive hazard from that, from the radioactive hazard that is in your garden already. And it is 1/10 of what's in your garden. And placed in comparison with the other materials we have discussed so far, there is a legitimate and fair comparison. And so, in fact, this graph shows you that the risk from coal ash is unimportant. The risk from short-lived intermediate level waste is less than that. And the waste from low-level waste is even less than that. And that is something that's not just my opinion. That's a proper technical opinion, subject to judgment by all my technical and scientific peers.